Nice small audience. I assume you can all hear me. I can talk reasonably loud. I haven't quite lost my voice yet. So look, we'll make a start. Many thanks to Raphael and Jackie for talking a bit longer. That's made me decide to shorten my presentation and leave out the demos. So because I pushed my luck too far with these demos, and I think, like Wednesday or whatever was right on the edge. If I do any more typing into keyboard, bad things are going to happen. The demos just aren't going to work. If you're interested in what I'm talking about, then come and see me later and I'll show you that stuff does actually happen that is on the PowerPoint slide. But that'll save us some time and we won't be late for lunch or the next session or whatever. So this session, as the title said, leveraging cloud-based services with OpenVMS. Now, Raphael and Jackie from the team here just talked about deploying OpenVMS on OCI and doing magic stuff like that. Now, back in I think it was 2012. I was actually working, before I started working for VSI, I worked for HP's cloud services team. That was a somewhat short-lived cloud services team because HP fairly quickly realized they couldn't compete with Amazon, they couldn't compete with Bookstore. And so they spent some disproportionately large amount of money trying to create HP cloud services and then essentially gave up on the idea and decided it would be better to work with Google and Azure and AWS. But anyway, during my time with the cloud services team, I gained a rudimentary understanding on how cloud worked. And even going back to those days in 2012, 2013, I was thinking, how can I plug this VMS system into this service that we've just implemented in HP Cloud? We'd implemented, for example, a message queuing service in HP Cloud based around, if you know me, you guessed it, RabbitMQ. How can we hook into that from OpenVMS? So going back over a decade, I've been playing around with various things about how you can actually hook your legacy OpenVMS applications into a cloud environment and leverage some of the good stuff that's there. So we're just going to do a kind of a whirlwind tour of some of the possibilities, okay? Cloud providers like AWS, like Azure, Google, whatever, they provide a myriad of really quite cool and in many cases incredibly useful services, right? They provide more than just compute and storage. They provide databases. They provide message queue streaming services, services for around AI, analytics and kind of things, you name it. And depending on what your budget is, you can do a little bit more with these services. You can go for the basic entry level stuff, which is what you would have seen if I'd run my demos, because I'm doing everything on the cheap. If you've got a slightly bigger credit card, and Liam knows all about blowing money on Azure on his credit card, you can buy additional services that might, say, give you a higher level of availability for a particular cloud service, right? You go and buy database as a service, you take the cheap option, all bets are off. Your data may or may not be there tomorrow. You spend a little bit more money and they'll guarantee you 9 nines availability or something like that, okay? But that's all the way through these extra value adds, all the way up to government regulatory compliance, maybe for data that needs to be in a particular geographic location for government or some compliance reason, et cetera, et cetera. You can pay more money and these things will happen. Cloud providers will love them for it. So just a couple of quick copy and pastes from lurking around inside the Azure cloud environment. It's a little bit difficult to read, but essentially here you've got database services offered by Azure. There's 22 of the damn things, right? When I created this slide, there could be more now. Integration tools and so forth. This is just a slice of some of the integration options available. 16 services there. If you then look across all the services, I can't remember what, there's hundreds on Azure, right? Literally hundreds of services. And there's a lot of great stuff there. How can we take advantage of it from an OpenVMS perspective? Okay. So just a little background on, I mean, the way cloud services and so forth evolved, I suppose AWS kind of championed that. They were kind of at the forefront, I suppose, of creating these services. And the way they approached it, which everybody kind of followed suit, it's sort of a logical thing to do, was to use REST APIs, which provide a ubiquitous means of interfacing with these cloud-based services, essentially over HTTP. I'll go into that a little bit more very soon. But in this paragraph up here, this was me exchanging an email with Adam Hocknielsen, one of our salespeople in Denmark, actually, our sales lead. Actually, he'd probably be upset being called sales account manager. But anyway, Adam had been having a conversation with a customer that said, hey, can we hook into Google's cloud storage from OpenVMS? I'd really like to sort of, copy my backups into Google's cloud storage. And this is part of my response back to Adam, that, give me half an hour or so and I'll investigate what might be possible. I said to him, quite often with this stuff, and this will come up a couple of times throughout this talk, quite often with these things integrating with cloud services, the technicalities of getting the bits and bytes going backwards and forwards, deploying service requests and so forth, is actually quite straightforward. The pain in the butt is getting started. Authentication is a pain in the butt, and you tend to find that every provider does it just slightly different. It's the same general theme, but the implementation will be a little bit different. Worst one is Microsoft. We won't go there. I mean, I'm not saying it's good, bad, or indifferent. It's just fucking annoying. But anyway, a lot of these, but hey, I accepted the challenge. So REST APIs, ubiquitous way of interfacing with these cloud services. You want to deploy a new VM, or if you want to interact with Google's cloud storage, you do it through a REST API, right? What is a REST API? We'll talk about that a little bit later on. But there are some services that it makes no logical sense. Technically, it does not work. You cannot interact with a relational database using a REST API. Well, you sort of could, but it probably would have bad results. Okay, so there are other cloud services that do not use those RESTful APIs. Maybe they use them for administrative purposes, right? You want to add a new user to your database or something like that, it's a REST API call. But when it comes to actually interacting with and using the database, we're going to use the native database protocol. Likewise with message queues and streams and so forth. You can, and I've got an example in this talk of interacting with queues and streams via the REST API. But more often than not, particularly if you want to get extremely good performance, you're going to use the native APIs for those products. So that might be something like AMQP, the Advanced Message Queuing Protocol, the MQTT if you're doing Internet of Things type work, the Kafka protocol if you're doing event streams and things like that. Obviously, with databases, if you're talking to a Postgres database, you're using Postgres wired protocol itself. Okay, so like I say, databases, REST API, and it's a good query. So, what is this REST? It's not me lying on the bed, feeling a little bit tired and falling asleep. REST stands for Representational State Transfer, and it's a rather fancy and somewhat incomprehensible term for a fairly simple concept. And it was introduced by a guy, Roy Fielding, in 2000, in his PhD thesis where he talks all about this concept. It's really no big deal. I mean, you're basically using URLs. It's not constrained to HTTP. It applies to any protocol, but it's most commonly used to HTTP. And you're making use of the verbs that those protocols support. In case of HTTP, you put, post, get, delete, whatever. Okay. So nothing particularly magical, fancy name. It's an architectural style. It's not a standard. You can't go and buy a book that says this is the standard, but there are generally approved ways of implementing REST APIs. Gives you a lot of flexibility, really. I mean, if you date, I think I've got it on one of the next slides, but if you go back in time, who's old enough to remember, the days when Gartner was promoting web services? This goes back into the late 90s and the 2000s and so forth. Now, SOAP-based web services, great, but like anything that's designed by committee, it's ridiculously complicated. We probably only use about 10% specification in the end. REST is a lot simpler, easier to use, and because of that, I think in part, a small part, it's actually gained a lot more popularity and won out over those SOAP-based web services over the years. Okay, so we've got REST APIs. Cloud providers provide online tools. Maybe they're written in Python, Java, or whatever. If you could run on the Linux or Windows system, maybe in some cases we could run them on the VMS system as well to interact with those cloud-based services. But your mileage may vary, as I say, using some of those things in VMS context. So that brings us to, okay, I've got a program on VMS and I wanted to, or I'm going to write a program on OpenVMS and I want it to interact with some cloud-based service in a RESTful manner. How do I do that? It's actually not that hard, okay? What do you need? You need something that you need a library you can link into your 3PL code. You probably need something that's going to parse and handle the JSON or XML messages that you're going to see and receive. And the biggest challenge, like I said before, quite often is dealing with authentication. Dealing with some of the XML and JSON messages, response and request messages that come back and go across the wire, that can get a little bit tedious, but kind of once you've done a few of them, you get on the roll and it becomes a lot easier. So ultimately, from a programmatic perspective, if you're going to sit down and write something in C or whatever, you're going to need an HTTP client and you're going to need JSON or an XML parser. This is just a little graph, getting back to my point before about SOAP-based web service and RESTful-based web services. The blue line is the popularity of REST APIs. Red line is the popularity of SOAP-based web service. So clearly, the SOAP block has all been used up and gone away, and most people are doing REST products. Okay, so we're wanting to write a C program that's going to interact, say, with Google's cloud storage, for example. What do we need? We need an HTTP client API. I typically use libcurl for that. It's pretty comprehensive, provides all the functionality we need. It's got debugging capabilities, performs well, and VSI provides new versions of curl every so often, whatever. Various options you can find on GitHub or wherever for handling parsing JSON or XML. It's not particularly difficult. And even the curl command line utility itself can be very useful just for getting you started, like prototyping and testing things. You can create by hand, or whatever, create a little XML or JSON document, type the appropriate curl command, and actually get some response back from the web service. Once you've done that, prototype it, you can then start incorporating the necessary functionality into the C program. And like I said, there are some things, databases, message queues, etc., that you're just not going to integrate with via a REST API. You're going to use the native wire protocols that are supported by those products. Microsoft SQL Server, then you need to use the TDS protocol, the Landscape protocol. Other databases have their own proprietary wire protocols. Likewise with message queue. Talk a little bit about some of these things later on. So cloud storage, like I say, Adam has been talking with the customer about this. How can I copy files to and from Google Cloud Storage? So I spent a little bit of time looking at that. It's many cloud providers, all the cloud providers provide some sort of object store and a REST API within that. Okay, and Google's one is probably one of the more comprehensive, more scalable. AWS. Essentially, all very similar, not a problem. This is a moderately sophisticated REST API, and there's a lot you can do with it. Obviously, the simple things you want to do: upload, download files, do a listing, what files are in a particular folder or whatever, those determined buckets in this case, the object store. There's a lot you can do. So I set about creating a prototype, and like I say, if you want to see a demo of some of this stuff, but I'll find later. But this particular demo here, very, very simple. The program I created, I called it GCS. It works like a normal VMS command line interface. I'm saying what bucket I want to use, which is essentially a directory. Fetch token. This I mentioned this is the third time I've said about authentication being paid in the butt. And that's essentially getting a session token for me for this particular session for interacting with Google's cloud storage. And after some period of time, I don't know what that period is, that token is going to expire and would need to be renewed. I need to fetch a new session token. But obviously, for the purposes of what you're doing here, uploading, downloading files, etc., it's not a big deal. You're probably not going to expire the session token unless you're maybe uploading a terabyte or something like that. But essentially, what I'm doing is I'm going in there, I'm fetching a token, I've now got an active session. I do an ls command because I suddenly switch into Linux mode, right? And there's no files. So these are all commands you're typing in my little program. And then I put start on H, so it's going to gurgle through and it's going to upload the files that's listed there. I then did another ls, yes, it has actually uploaded it, right? It's given them some wacky line type with application object screen, that doesn't really matter. and it's told me when it's uploaded things. Okay. And hey, it works, right? So we can upload download files from Google Cloud Storage. Okay, neat. When this program starts up, when you run this GCS thing, it's actually going to load a configuration file which has all of these squiggly characters and secret keys and refresh tokens. And don't quickly try and copy them because I changed the letters. Can't sabotage my cloud storage. But essentially, you need at least three pieces of information. You need client secret, you need the refresh token. I can't actually remember what doesn't matter. And I obviously need my client ID on Google Cloud Storage as well. And with these pieces of information, that's sufficient information for me to actually get the session token. So this talks about a little bit more here, but that's the text out here is exactly the same. But this is another example where I'm uploading and downloading, what is that, about a 15 megabyte file or something like that. This was from within the VSI network. I mean, I wasn't trying to get blinding fast transfer rates or whatever, but it came out at about 3.7 megabytes per second. Maybe not enough to upload and download big backup files, but not too bad. I could probably do better. Queues and streams. So many cloud providers provide some sort of message queuing service, and some of them even include a RESTful API that allows you to hook into that message queuing service. One of those being IBM's MQ. So if you get an account on IBM's cloud and spin up an instance of message queue, you can actually use their REST API to get messages. Now, obviously, via the REST API, you can only use a subset of the functionality that's provided by IBM's MQ, but for many purposes, that's absolutely more than sufficient. Now, we had Willow Technologies have almost finished the work of porting IBM MQ to x86. Testing is passed. They're at the point of packaging things up and making some sort of beta available. I'm not sure when that's going to be, but that's the latest update I had. But we had a customer here who was very keen to get to x86 sooner rather than later. And one of the barriers to that was that their OpenVMS programs, which I think were written for Fortran, actually needed to interface with IBM MQ server somewhere else within the business. How can we do that? Well, you can actually do it using REST API. Problem. So we actually set about creating an API, a fairly generic API that you can link into your Fortran program, or COBOL or C, anything you like, it doesn't matter. It's typical sort of VMS stuff that uses descriptors and all the normal stuff you'd expect from a VMS application programming interface. But under the hood, it's calling this MQ REST API. And this was some feedback from the customer here, and this text, which you probably can't read, they were putting and getting something like about 8,000 messages, a couple of thousand bytes each, so not too many messages probably, but this is a simple test they were doing. What they found was that this was almost as fast as using real MQ, i.e. without the REST API on top of it, just using the native MQ API. So in some cases, and well done to IBM, I guess, but in some cases, the performance of these REST APIs can actually be very, very good. So, if you have a similar requirement, let us know. As I say, this has worked very well. I'm very pleased with it. More on queues and streams. So MQ there, that's a tool that we can provide to you if you have to need to hook into MQ in some way, like MQ. We also have APIs for Apache Kafka, and I don't like Kafka. I don't know why I don't. I prefer this thing called Red Panda. It must be something about small furry animals or something. But Red Panda is actually a C++ implementation of Kafka standard. I use the term standard fairly loosely. It's just much easier to spin up and get going. To be honest, it's probably a bit faster as well. But regardless, if you need to do event streaming in cloud environment, you can do that with Kafka in your favorite cloud provider, or you can do it with Red Panda on their cloud. And all you need is the Kafka API, which we provide on OpenVMS. probably needs an update. I'll be looking into that. But it works pretty well. I've noted there that Kafka client API can be a little bit fiddly. It's got a lot of knobs you can adjust, right? And positioning of those knobs, shall we say, on OpenVMS is not the same as the positioning that you might have on a Linux system. So finding the exact right settings can take a little bit of experimentation and fiddling around. But once you get there, it works well. We also have APIs for RabbitMQ, implementation of the advanced message queuing protocol, and RabbitMQ, which is compatible message growth with RabbitMQ. And also for MQTT, the message queuing telemetry transporter that's been known. Now we just use the acronym. But just here with this box here and down here, a friend of mine, Carl in Sweden, set up RabbitMQ as a service back in 2013. So he was really at the forefront of this stuff. He actually realized that you could take something like this, put it in a cloud environment, and provide a service around that. And he's been very successful with his company. But what they do is their hosted and managed RabbitMQ deployments can run on Azure, they can run on Google, they can run on AWS, right? Whatever, doesn't matter. So he's not providing the cloud infrastructure that underpins the service he provides. He's leveraging what companies like AWS and Google and Azure provide. And so you can, if you go and deploy something with Cloud MQP, you can say, I want it running in AWS US East, which, given recent events, maybe you don't want to do. But you can basically choose where you want these things to be. AWS themselves also provide a hosted RabbitMQ service. I think the date there is 2020, they started doing that. So cloud providers, provide these services to providers like Cloud MQP guys or whatever, who have a product, set that up to run in the cloud environment, and you can sell that as a service and it's supposed to apply those requirements. Queues and streams, it's like message queuing has been around almost forever. I mean, I've done message queuing one way or another, I would say just about the entirety of my career, which dates back to the 24th of February 1992 when I started with Digital Equipment Corporation. Message queuing has been around for a long time. It's gone through various incarnations. And now it's being found and adopted by a new generation who have grown up with the world of cloud services and things like that. So this is a friend of mine, Alvaro, who now works for Microsoft. But Alvaro was one of the people who worked with RabbitMQ and the advanced message queuing protocol in the early days. And he shared this slide with me from a talk he gave in Berlin a couple of years back. It just gives you some insight into how heavily used message queuing is within the Azure cloud environment. You're talking petabytes of data on a monthly basis. You're talking terabytes of total message size on a daily basis or per minute even. The number of messages that are going through these queuing systems in Azure is quite phenomenal. Okay? So new generation seeing the benefits of decoupling and other values, buffering and so forth. These services are being well used. We can actually allow you to interface with Azure Service Bus, which is Microsoft Azure's cloud implementation of the advanced message queuing protocol. You can do that on OpenVMS today using a thing called Cupid Proton, which is a C++ client API. You can use that with OpenVMS 8.4-2L3 and x86. Actually, you can probably use it on 2L1 as well, as long as you've got the RDBL updates. But that works really well. And like I say, want to see anything like that, put it later. Looks a treat. So from your VMS system, you could quite happily publish messages into Azure, quite happily consume messages out of Azure Service Bus. So this was going to be the demo. I mean, incredibly trivial. Just push the messages up into the queue, pull them out. What I suppose I'm trying to say with this slide is the whole purpose of this talk is to kind of illustrate the fact that if you've got some legacy application, maybe it's written in COBOL, maybe it's written in BASIC, it doesn't matter. you can actually hook it into these cloud services that I'm talking about using the APIs that I'm referring to. Okay, so this is actually part of a blog post I wrote as far back as 2015. Remember me saying at the start of the talk how at that time I was working great for these cloud services team. And, you know, as a bit of a side project, I was always thinking, how can I actually do something with VMS, allow it to interact with these cloud services? So this is a blog post I wrote over 10 years ago, which talks about doing this stuff. There's a lot of these, you know, legacy code out there. It's running your businesses, right? It's doing a great job at it. But for whatever reason, you potentially need to integrate it with some new thing because the CTO says so. How do you do that? Hopefully what I'm illustrating here is that may just be possible. And, you know, if what I'm saying today helps, great. If you think I might have some other crazy idea, then come and talk to me. See what we can sort out. Databases, okay, it's another common one. That sounds like a good idea. My DBA is retired. Let's go and stick our database in the cloud and we'll let Microsoft or AWS look after it. Okay? Now, like I said, you're not going to interact with a relational database like SQL Server via a REST API. We're going to use the native protocol, which in the case of SQL Server is TDS, that's for the data stream protocol. And there's an open source implementation of that with free TDS. We've developed a number of tools around free TDS that you can use with your applications on OpenVMS to hook into SQL Server or Sybase. Sybase uses the same protocol, albeit a slightly older version of it. But in general terms, if you've got a C++ API that you found on GitHub to talk to a particular database, there's a fairly high probability, particularly on x86, where we've advanced the standard support in C++. A fairly good chance you'll be able to port that API to OpenVMS and do something useful with it. To get stuck again, as I say, feel free to contact us and see what we help. But no problem talking to Postgres or CockroachDB, which is another cloud-based database that I mentioned later on. They both use the Postgres wire protocol. Right. SQL Server, I mentioned, obviously, MariaDB, MySQL, they have their own open source APIs, I suppose. It's not too difficult one way or another to talk from OpenVMS directly to one or another of these databases running in one or another of those cloud environments that I've Okay. CockroachDB. So I don't only just like furry animals, but also creepy insects. And I was going to do a demo on this, but as I say, I'll run out of time because I'm talking far too much anyway. But CockroachDB is relatively new boy on the block. I mean, it's maybe 7 or 8 years old, something like that. Implements the Postgres wire protocol. But the interesting thing about CockroachDB, which is provided as a cloud-based service, is it is a genuinely distributed relational database. Okay, so the database is distributed across many nodes that you want. If one or more of those nodes goes down, maybe you'll notice degradation in service, but you're not going to get your data loss and all that sort of good stuff. So quite a nice database platform. ASIC compliant transactions, all that good stuff that we're used to. There's some other fancy things like geo-partitioning, taking advantage of what the cloud environment provide in terms of where the resources are placed. And these guys provide a managed database cloud environment. Like I say, no issues communicating with that OpenVMS. The demo I was going to give basically involved taking some index RMS files, running them through this thing called RFS, which is actually part of our RMS change data capture solution that understands what to do with index RMS files and actually has the ability to convert records into SQL statements. So what the demo does is it will actually read a set of index files and it will create tables in a Cockroach database instance, which just run a simple program that proves that magic happened when the data is indeed in Cockroach and we can get it back on our OpenVMS system. Okay. Now, InfluxDB comes with another database, but this one you couldn't interact with in a RESTful way because it's not relational. It's a time series database which is used for storing metrics, performance metrics, whatever metrics you happen to have. Key point is it's optimized for dealing with time series data. It's not something that, you know, a bank or an insurance company or whatever might typically want to use. Maybe they do, but probably not that sort of thing. More appropriate for Internet of Things, where maybe you're taking a whole pile of measurements, possibly a SCADA environment, where you're taking a whole of measurements and you're plugging them into InfluxDB. It scales massively to store billions, trillions of data points, whatever, that will handle it very, very well. Probably not so many use cases on where you want to hook into this from OpenVMS, but where I've been using it, and I talked about that on Wednesday, is in conjunction with this little thing that I refer to as Bowl, which allows you to collect data in near real time from sequential files and various other data sources, and make that data available off of OpenVMS as quickly and efficiently as possible. So I'm using InfluxDB, and I will. No, I do. You can actually hook that up, and I've got it hooked up so it can send to you T4 data coming through in near real time. Okay, and there'll be a diagram of this coming up somewhere on the side. I talked about Azure and some of the services it provides. Not surprisingly, Microsoft provide SQL Server as a service. And again, because we can do the free TDS thing on OpenVMS, we can hook into SQL Server running in Azure. So what this demo was going to do was actually do an automated conversion. Sorry, Bench. I can do these things too. An automated conversion of an RDB database straight into Azure. Okay. So this little tool, this thing, you probably can't read it, it's called RTO. It's actually something I wrote way back in 2006 for a project we were doing down in New Zealand for a local customer, where they wanted to move from RDB to Oracle. So I developed this tool, RTO. The R stands for RDB, and the O stands for Oracle, so RDB to Oracle. Very imaginative. Back in 2006, and it worked really well. So what I've done over the past 2 or 3 years on and off is just enhanced it, and really it wasn't all that difficult, so that it can actually handle other databases as well, other target databases. So in this case, I'm using RTO to say my target database in SQL Server. So you probably can't read the script from here, but basically I'm saying set target database in SQL Server, attach source, which is an RDB database, attach target, and it's this great big long string because, you know, it's always complicated to connect to services in cloud, stuff like that. Then I've got a command that says drop tables, which just in case I've already created the tables in Azure, it's going to drop them. It's then going to create the tables. So it's going to actually look at the metadata in RDB. It's going to create equivalent tables in Azure SQL Server. I'm then doing copy tables, and I'm converting after every so many records, in this case 128, makes it a little bit faster. And it's then going to slurp the data out of each of the tables in the RDB database and push them across and populate the database in Azure. Not blindingly quick, because like I say, I'm a cheapskate. I didn't go for the expensive option on the SQL Server database, but technically this actually works. So that's it. I've got an RDB database, it's a database, it's simple enough. Is it perfect? No, it's not. We won't go there. Rick glosses over the detail. Monitoring. So monitoring is another one where cloud-based services can actually be really, really useful. Okay. And Liam's done a lot of this in his former life, and will probably continue to do so going forward, working with us. But our VMS SPI product is more than capable of publishing alerts and so forth into various cloud-based services. So if you're using Splunk, PagerDuty, Datadog, Dynatrace, whatever in cloud, down the bottom here is Datadog, Variable is treated again. You can configure VMS SPI to send the alerts to those cloud-based incident management systems. All right? And at one stage for DNS is in the room, but I had DNS set something up with PagerDuty, which is the most annoying thing on earth, this PagerDuty. When I was working for the cloud services team, we used PagerDuty to tell us when something was wrong. And this is the most pissy and annoying thing. You cannot avoid it, right? It sends you text messages, it rings you, it just keeps coming at you. There is no way you can avoid missing out on a case coming through. So VMS SPI can quite happily integrate all of these things. The other point down the bottom here that I made is that VMS SPI can also hook in with Prometheus, which is a very popular monitoring solution these days. Because what VMS SPI is doing, obviously, it's keeping an eye on your system. Are bad things happening? Is someone trying to break in? Do I have a looping process? The list goes on. Now, in order to perform some of those functions, VMS SPI has to collect some number of metrics. It's not comprehensive, like it's not everything that get SYI or get JPI returns, but it has to collect a subset at least of those metrics. And it collects some number of fairly useful ones, right? So what I decided to do is to actually make those metrics available via the Prometheus interface. Why not? So what is this Prometheus thing? Okay, it's an open source monitoring and learning solution, right? So, for example, what Liam did, in addition to just having VMS SPI itself raising the alerts, he leveraged Prometheus and Grafana to actually have it doing a lot of the alerting. Prometheus is much more, or not necessarily more sophisticated, but just different rules. And that worked very, very well. Prometheus at its core has, again, a highly stable and efficient time series optimized database. But the way it works, I kind of quite like it because it's almost like grubby and simple. It's elegant in its simplicity. Essentially, the way it works, I use VMS SPI as an example. Within VMS SPI, if you enable this feature, there's actually an embedded web server running in VMS SPI. And if you browse to the right URL, you get back not even HTML, it's just a text document. It's just like metric, current value, metric number, current value, metric number, current value. All this thing is doing, all Prometheus is doing, at prescribed intervals, it's going straight to that URL. These are the values at this point in time, and they're saved, right? And so you can just have Prometheus list of all the URLs you want it to go to, and it just gathers up all those metrics. And I mean, I'm glossing over again a lot of details, but at its essence, it's that simple in terms of how this thing works. And you then look it up with something like Grafana, which I'll also talk about very soon, which allows you to create pretty graphs and do fancy things around the work and stuff. Okay, so yeah, Grafana, I won't bore you too much with the details, but it's, how have I described it there? Okay, it's data visualization. Yes, look, it's great for drawing graphs and doing it. Right? Now you can get all of this stuff. Like you can get Prometheus for free. You can download it. You can run it on your laptop. It's not a problem. Likewise with Grafana. Or you can go broke and you can buy cloud-based services, cloud-based implementations. In which case, Grafana or the Prometheus guys, there's some managed service, right? They're providing value for money for doing something for you. Or then in cheap state, I can even use the free tier in the cloud service. That's generally enough just for a demo or to prove the concept and so forth. But here, for example, this is some pretty simple line plots that I've created with Grafana. It's pulling the data out of Prometheus. Prometheus is getting that data from VMS SPI. So in this case, the URL down the bottom, if I clicked on it, it wouldn't work exactly inside the VSI network. But if it was, we would pull up the graph a bit like that. Now, it doesn't have to be VSI's network. You could be running Prometheus and Grafana, as I say, somewhere. A much more sophisticated example, illustration, but was the thing I talked about on Wednesday, where I'm using the little bowl program, which, as I say, is designed to read a near real-time stream of data sources, RMS files, whatever, it doesn't matter. And just going for broke in terms of some of the services I talked about previously, I had bowl set up to read data from T4, publishing it to a Cloud AMQP instance hosted on AWS, publishing that data into messages being issued out of Gravity View by something called Telegraph, which is a generic consumer for InfluxDB, pushing the data into InfluxDB, and I can read graphic using Grafana. Kind of a little bit silly, but hey, it works. And like I say, this is VMS almost indirectly leveraging multiple cloud-based services. That's pretty much about it, really. As I say, the point I really want to get across is that these cloud-based services contain some useful stuff, right? I mean, the most common use case, I suppose, for VMS would be integration, doing whatever, storage, and potentially database as well. All of this stuff is possible. Sometimes there's a little bit of pain and suffering at the start of the process to actually get connected. As I've said, authentication can be a real pain in the butt. But once you get past those initial hurdles, it's generally not too hard. It's you know, not trivial, but it's fairly smooth going. And you can make pretty good use of those services from your VMS systems if you want to. Whether it's to integrate with a business trading partner, business partner, whatever, doesn't matter, whatever reason, I don't know what reason you might have. And obviously, if you think about what Jackie and Raphael were talking about in previous talk in this room about what we're doing with deploying OpenVMS and x86 to cloud environments, potentially some of this stuff becomes even more relevant, right? You're running OpenVMS on x86 in cloud, you're actually in a much better position from a performance perspective to take advantage of some of these services. It possibly becomes far more relevant. Okay, so that's pretty much about it. A pretty picture, but yeah, any questions?